So to factor the expression x cubed minus 2x squared minus 9x plus 18 completely, we notice we look at each of the terms and we see that there's nothing common between them. Okay? So that means we're going to have to factor by grouping. Okay, so factor by grouping means we're going to look at the first two terms. We see there's a GCF there of x squared. And then we're going to look at the last two terms. And we see there's a GCF of -9. Okay? So, the GCF here, what's common is the x squared. So, we are going to, hey, go ahead. So we're going to, there's a GCF of x squared, right? That's a common term in both of these. We're going to divide by the x squared. And what's left? Well, x cubed divided by x squared. That's just x to the 1, right? We subtract the exponents. 3 minus 2 is 1. Now, we have the x squared. Well, that's going to cancel out. So we're going to get -2 here. And we don't really put the 1. Okay? Now, the GCF here, it's -9. So I divide by -9 on both. The -9's cancel out. So I'm left with x. 18 divided by -9 is -2. I notice there's a common term, or common factor. So I can factor that out. So I'm going to be left with x minus 2. And what's left is the x squared and the -9. So I'm going to put that there. Now I notice that this is dots. I can factor that even more. How do I factor x squared minus 9? What is that going to become? That's going to be plus minus. That's going to become x plus 3, x minus 3. And that's our answer right there. It was x cubed minus 3x squared minus 3x squared plus 4. Which statement is true? So if you guys recall from the remainder theorem, right, the remainder theorem says that if we take a factor, okay, and we substitute into the actual polynomial, if it equals 0, it's a factor. If it's not equal to 0, it's not a factor. Okay, so notice they're all talking about is a factor. So the only time that something is a factor is when it's equal to 0. Okay, that means we can eliminate 1 and 2. Okay, it has to equal to 0. Now, x plus 1 is a factor because p of 1 equals 0. Now remember that we don't substitute that number, we substitute the opposite. Okay, so 1 and 1, notice it's the same sign. Here we have to get the opposite sign. So x minus 1 is a factor because p of 1 equals 0. We always substitute the opposite, so the answer is 4. So it says, given f of x equals 2x squared plus x minus 3 and g of x equals x minus 1, express f of x times g of x minus f of x plus g of x. as a polynomial in standard form. In other words, we're going to write it down with the exponents from highest to lowest. Okay, so this is going to be quite involved. We're going to have to multiply f of x times g of x, and then we're going to have to add f of x and g of x and subtract that from the product of f of x and g of x. Okay, so let's do this one over here in this space. Let's see, we have, actually, let's do this in the bottom. Okay, so let's do, remember, we have to do f of x times g of x minus f of x plus g of x. So let's do f of x times g of x first. So that is going to be 2x squared plus x minus 3 times x minus 1. So we have to do the distributive property. So x times 2x squared, well, that's 2x cubed, right? And then x times x, well, that's x squared. X times negative 3, that's negative 3x. Now let's distribute the negative 1. Negative 1 times 2x squared, that's negative 2x squared. Negative 1 times x, that's negative x. Negative 1 times negative 3, positive 3. We're going to look for like terms. I see an x squared here, a negative x squared. I see a negative 3x minus x. So I'm going to put it all together. I'm going to have a 2x cubed. X squared, 1x squared minus 2x squared is negative 1x squared. Negative 3x and minus x, that's minus 4x. And then we have plus 3. Okay? Now, let's do f of x plus g of x. So let's see. We can do it in vertical form. We have 2x squared plus x minus 3 plus x minus 1. Well, if I add that, that's going to be negative 4, 2x squared. Okay, so we just did that. So now we have to subtract when we subtract, that essentially changes the whole sign of that one. Okay, so that's going to be 2x cubed minus x squared minus 4x plus 3 minus 2x squared minus 2x plus 4. Well, I see a minus x squared and a minus 2x squared. I see a minus 4x minus 2x, positive 3 and a positive 4. So I'm going to rewrite it in standard form. That's going to become 2x cubed. Negative x squared and negative 2x squared, that becomes negative 3x squared minus 4 and negative 2 minus 6x plus 7. Right? And it's in standard form. Notice that all the exponents go from highest to lowest. Right? Cube squared 1. right? That's it, that's the answer. Or is that we're going to use long division. Whatever's on the bottom, that's what we're dividing by, or how many times does x cubed plus a go into x cubed plus 9. So we're going to put that outside. And then x cubed plus 9. Remember, from long division, the first step is divide. Then goes multiply, subtract, and then bring down. Okay, in that order. So x cubed goes into x cubed, so remember we divide the first terms. Well, x cubed goes into x cubed one time. So now we multiply. 1 times x cubed is x cubed. 1 times 8 is 8. Okay, we are going to subtract or change the sign of everything. So that becomes negative, negative. Okay, and then we add. So this cancels out. 9 minus 8, or 9 plus negative 8 is 1. So we have 1 plus 1 over x cubed plus 8, which is what we proved. So we proved that algebraically. So they tell us that both of these terms are equal to each other. Okay. And we also have to determine and state y in terms of x. In other words, we have to get y by itself. So we set those both terms equal to each other. This is going to become our denominator. This is going to become our numerator. So we can translate from a radical notation to an exponential notation. So this is going to become x to the 5 over 3. Okay. Now to get y by itself, okay, that has to equal to 1. So we have to multiply by the reciprocal. Okay. And we have to multiply by the reciprocal on the other side as well. So when we do that, that becomes 1. So y to the 1 is y. And then this is going to become x to the 30 over 15. Well, 15 goes to the 30 twice. So this becomes x squared equals y. So we have y by itself. And so this is y in terms of x. We can also do it the other way around. So we're going to have x plus 2. How many times does that go into x cubed plus 2x squared plus x plus 6? Remember the 4 steps of long division is to divide, multiply, subtract, and bring down. So guys, let's look up here, please. So x goes into x cubed. So we divide. X cubed divided by x, well, that's x squared. So I'm going to put x squared here. Right, then I'm going to multiply x squared times x. Well, that is x cubed. X squared times 2, that's positive 2x squared. Guys, so make sure you follow along. Okay. So now we're going to change all the signs. This is going to become negative, negative. So what ends up happening, this cancels out. Okay, and then we have 2x squared minus 2x squared, well, that is 0. Okay? So now we bring down the x. So how many times does x go into x? Well, that's going to be 1 time. 1 times x is x. 1 times 2 is 2. And then I guess we can bring down the 6 as well. So that's going to become negative. Negative. That cancels out. So we get 4. So that's going to be x squared plus 1 plus 4 over x plus 2. So if we look back at our answers, it's going to be 2. Guys, so 3x squared plus 7x minus 20 and g of x, x minus 2. So it says state the quotient and remainder. Obviously they want us to divide, long division. So we're going to do x minus 2, 3x squared plus 7x minus 20. So how many times does x goes into 3x squared? So 3x squared divided by x. So that's going to be 3x. So 3x times x is 3x squared. 3x times negative 2 is negative 6x. That becomes minus plus. That cancels out. 13x minus 20. Well, 13x divided by x, well, that's 13. So positive 13, 13x minus 26. So this becomes negative, this becomes positive. So that becomes 6. So that's going to be 3x plus 13 plus 6 over x minus 2. X, if you recall, the first thing we have to do is identify the LCD. Okay? So the LCD, if we look, we have an x, a 3, a 3x. So it's the greatest common factor between them, or the greatest common multiple. We see that one has an x, one has a 3, the other one has a 3x. So the LCD will be what? What encompasses all the factors? So basically you put it together. So the LCD will be 3x. Yeah? So we have 1 over x minus 1 over 3 equals negative 1 over 3x. So we have to multiply what's missing. We see that the x on the bottom, right? What's missing? On the left. 3. Okay. That's missing. So that's missing a 3, so we're going to multiply the same thing on the top and the bottom. How about this next one? What's this one missing? An x. And the last one is not missing anything, so we don't have to multiply anything. So now we distribute 3 times 1, well, that's 3. 1 times x, well, that's x. And then negative 1. So the next step you forget about the denominator because the denominators all are the same. Okay, we have the same denominator, so we can combine it. So this becomes 3 minus x equals -1. So let's see if you guys can finish itself. Everybody look up here. We subtract 3 on both sides. So we get -x equals -1 and -3. That becomes -4. So we have to get x by itself, but there's a negative. So you can just multiply by -1 on both sides. That makes it positive, right? Negative times negative is positive. -4 times -1 is 4. Okay, so that is x equals 4. To do this algebraically, okay, solve for x. We're going to look at the denominators here. We have x plus 3, we have 2, we have 6, we have 2. So we have to find the LCD. Okay, so we definitely see that one of the LCDs is x plus 3. And now, if we look at 2 and 6, we looked at the multiples of 2 and 6. The multiples of 2 is 2, 4, 6, 8, 6, 12, 18. We see that the least common multiple here is 6. So therefore, the LCD is going to be 6 comma x plus 3. Okay. Once we find that, we're going to put all the fractions together here. -3 over x plus 3 plus 1 over 2 equals x over 6 minus 1 over 2. So we look at what's missing. We compare the LCD, we compare the denominators, and we're comparing it with the LCD here. We're comparing it with this and seeing, okay, what's missing? Well, the first one is missing the 6. So I'll multiply that on the top and the bottom. The second one is missing the x plus 3. And not only the x plus 3, we also have to multiply it by 3. Because 3 times 2 is 6. So we multiply again. Okay? And then this one is missing the x plus 3. And this other one is also missing the x plus 3. This one here is missing the 3. So everything is complete. Now, the way we know that we're done is this is going to be 6x plus 3. We're going to have another 6x plus 3 here. 6x plus 3, 6x plus 3, right? Because 3 times 2 is 6. Once the denominators are the same, right? In order for us to combine fractions or add fractions, the denominator has to be the same. So since they're all the same, we can forget about the denominators and now we focus on the numerator. So 6 times -3, that's -18. 1 times that, well, that's going to be the same thing. So that's 3x. 3 times 3 is 9. Okay, this is going to be x times x, that's x squared. X times 3, that's 3x. Okay, and then we're going to have 1 times this, well, that's going to be itself. So that's going to be minus 3x plus 9. Right, we would do 3 times x is 3x, 3 times 3 is 9. So now, this is going to be, we can combine like terms, negative 18 and 9. And we can also distribute that negative. So negative 18 and 9, that's going to be negative 9. So that's going to be 3x minus 9. We distribute that negative to the parentheses. It changes all the signs in the parentheses. The 3x becomes negative 3x. That 9 becomes negative 9. So we see on the right-hand side, what happens to that 3x and negative 3x? Cancels out. So we have 3x minus 9 equals x squared minus 9. Yeah, we add 9. They cancel out on both sides. We move that negative 3x. So x squared minus 3x. What's the GCF? X. So we factor out the x. What's going to be left? X minus 3. So once we have it in factored form, right, we can set that equal to 0. So that means x is going to be 0. X is going to be 3.